Hello and welcome to Computer Science 30S. This is Liberty Basic. This is Lesson 2, left string, mid string, and right string. So we spent some time in Lesson 1 looking at the various, some of the string features, functions in Liberty Basic. Let's look at three a little bit more closely here. These functions remove single characters or groups of characters from strings. They all do the same thing, but their starting points are different depending on what is needed. And I think you'll understand what I'm saying when I show you some examples here. So left string removes characters starting from the left of the string, and you can remove as many characters as you wish. So for example, if name string is equal to Jonathan, spelled like that, and then I said initial string is equal to left string of name string comma 1, initial string will produce the initial J. So what it does is it takes left string will take from the string name string, it will take the first character. So the first character of from the left, the first character of Jonathan from the left is the letter J. So if you want to pull off that first letter, in this case here, to get the person's first initial, you would use left string, the name of the string you're trying to pull the initial from, comma 1. And the 1 just again takes the first character. If you want to take the first 2, you put a 2 there, and you'd have J-O. Much like in the example here. If I had initial string is equal to left string of name string comma 2, it takes the first 2 characters and will produce the letters J and O. You should note that if the number in the brackets inside the parameters, the arguments is 0 or less, then an empty string will be returned. If the number is greater than or equal to the number of characters in a string, then the entire string will be returned. So in other words, if I put name string comma 0, I would produce nothing. And if I did name string comma 10, it would produce the entire string Jonathan. So that's sort of how left string works. Right string works exactly the same, except that it starts counting from the right. So for example, if I went print right string, I'm right-handed, comma 12, it would produce right-handed because of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right-handed with the space. Notice that the space between the words right and handed is counted as a character. So when I counted 12, I got all the way to the letter R, and I got right-handed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The space counts as the 7th one. Again, if the number in the brackets is 0 or less, then the null string, the empty string, will be returned. And if the number is greater than or equal to the number of characters in a string, then the entire string will be returned. Okay, mid-string removes characters from the middle of a word. As you might have guessed, it can start from any position and remove as many characters as you want. So generally, the format of the function is mid-string bracket, the string you're trying to get, an index, and a number. And the index is the starting position. The number refers to the length of characters to remove. It is optional, and if left out, then the function returns all characters starting at index to the end of the string. So for example, if you had a really long word string is equal to supercalifragilisticexpialidocious, word inside the word string would be set equal to mid-string, really long word string, comma 9, comma 2, and it would pick the starting at the 9th character, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I'm taking 2 out, it's going to select I and F. So that's one way you can pull a word out of a particular string. These functions can be used for a variety of reasons, rearranging the letters in a word or scrambling. Removing letters to check the letters or digits in a password would be one of the most common ones. Quite often you'll see programs online, that type of thing, have certain password requirements, and so we need to remove letters from the password to ensure that the password requirements have been met. So in fact, that's what you're going to do for a practice assignment, is do a password checker. So for example here, a website requires users to use a secure password that has the following restrictions. It must be between 6 and 24 characters long, must include at least one uppercase letter, must include at least one lowercase letter, must include at least one digit, and must include at least one symbol. So I'd like you to create a short program that opens a new window that looks like this one. You can use Freeform to create it if you want, if you remember how to do that. If you don't remember how to use Freeform, check with me in class, and I'll be happy to show you how to use that again. It then checks to make sure that the first name and last name fields are not blank, and that the password entered matches the criteria. So there must be a first name, there must be a last name, and the password must match the criteria that I just went over. So remember that pseudocode is simply a plan for the program. You will likely want to do this. I encourage you, as always, to make a plan for your program and not just start coding. Here's some pseudocode right here. I'm going to set up the window. We're going to get the contents of the password text box. You might need some help with that. You might not remember from grade 10 something like print exclamation contents question mark, and then the string that you're pulling out, whatever you want. And I think you have to use a hand hashtag here, so like it would be something like window dot text box or something like that. So that's how you use that to get contents out. You may need to actually go on Liberty Basic Help, search up contents, how to do that. That's how you get the contents of the password text box. You should set flags to no. You may remember from earlier lessons, a flag is simply a variable that stores a yes or no or a true or false value. Essentially, it stores whether or not something happened or did not happen. In this case, the flag is set to no. The password checks are not true yet. If we find an uppercase letter, we will set the uppercase flag to yes. So there's going to be a variety of flags based on these conditions. All of these flags must be set to no to begin with, and then if all the flags are then set to yes, then we know that the password meets the criteria. First thing to do would be to check the length of the password. If it's not 6024, then ask for a resubmit. That's an easy one. Then you would do a for loop to the end of the password. If it's say 10 characters long, you go a for loop from 1 to 10. Get each individual letter from the password, or each individual character, I should have probably said. Check for uppercase. If so, set the flag. Check for lowercase, set the flag. Check to see if it's a digit, set the flag. Check to see if it's a symbol, set the flag. If there's more than one uppercase letter, that's fine. All you're doing is just resetting the flag to yes. So basically, you're checking each letter in the password, checking for uppercase, lowercase, digit, or symbol. And if the answer to that is yes, then you set a flag to yes, and you keep on going until the end of the loop. If all the flags when you're done the loop are yes, then you print the appropriate message. And if any flag is no, then you need to print an appropriate message and ask for a resubmit. So a fairly simple program once you sort of have the plan in place. Again, the pseudocode is important. Make a plan, and your coding will go a whole lot faster. If you want to use freeform to set up the window, I would recommend that you do that. Okay, so again, this is just practice. I've got the solution here, and I'm going to make it available for you as well, just so you have some idea how this works. Let's just have a look and see. You can see that I've used freeform to set up my main window. I've got some nice comments here. Begin the GUI objects code. Here's all the window setup stuff. I get the contents right here. You may not know about CLS. That just clears the main window. Here's all my flags. You see that I'm setting the flags to default no. And the first thing I do is I check the length first. Length of password is equal to len password string. If the length is less than 6 or the length is greater than 24, then say length flag equals no, and print your password does not contain the correct number of characters, please submit. If the length is in between those, then I go ahead and continue with my else. Here I've got for x equals 1 to length of password. This is where we're going to loop through the characters of the password. We're going to remove a single character. Check character string is equal to mid string of the password string, comma x, comma 1. So the 1 simply pulls out one character at a time. The x is the index that's going from 1 to the length. That's going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you've got a 10 character password. I check to find out what the ASCII code number is. ASC value is equal to the ASC of check character string. That pulls out the ASCII code number. And then I simply check. If it's between 65 and 90, then I know that it's uppercase, and I set my uppercase flag to yes. If the value is between 97 and 122, then I know it's lowercase, and I set the lowercase flag to yes. If it's between 48 and 57, then I know it's a digit, and I set my digit flag to yes. And if it's between 33 and 47, or between 58 and 64, or between 91 and 96, then I know that there's a symbol in there, and my symbol flag is set equal to x. Yes. And I go next x, and I continue on with the next character in the password. Once I'm done my entire loop, if the length flag is no, then I wait for a resubmit. So I simply put a wait there. Otherwise, I check to see which flag is still, I check to see if the flags are all yes. So if I've got a yes and a yes and a yes and a yes, then I close my main window and my password is correct. Otherwise, I print the following errors occur with your password. Please resubmit. And so any flag that is still no, I print an appropriate message. And then I simply wait again for the user to re-enter. Let's just press play here and see how this works. Okay, there's my name. And I'm just going to put a password of 1, 2, 3, 4, 5, 6. I've got no uppercase letter exists, no lowercase letter exists, no symbol exists. So if I resubmit, let's go 1, 2, 3, TEST. I still don't have a lowercase one. Put ABC at the end. No symbol. Let's try a exclamation. And there we go. Password is correct. I'll provide this code for you. You can look at it if you want. If you should have tried it, at least given a good attempt at it, and then moved on to the next part of the lesson. You should pause here. Okay, so now the assignment for this lesson is based on social insurance numbers, or SIN numbers. The Government of Canada issues social insurance numbers to all Canadians as a form of a national ID. You should all have one by now, probably. SIN numbers are not just 9-digit numbers. There's a check to see if they're a valid 9-digit number, and the government uses what's called the Loon algorithm. And if you want to look that up on Wikipedia, there's the link right there. It's actually quite complicated. Social insurance numbers can be validated through a simple check digit process called the Loon algorithm. It's quite complicated here, and it actually depends on where you were born as well. So the 9-digit number can be quite useful. You can read through that on your own if you like. I'm going to simplify things a considerable amount. We're going to use the simplified version. You're to take the first 8 digits and add them all together. Then divide this sum by the last digit in the social insurance number, and this should result in an integer value. In other words, the last digit goes evenly into the sum of the first 8 digits. And allow me to show you with an example here. So if I have the social insurance number 1, 2, 3, 4, 5, 6, 7, 8, 9, I take 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, the first 8 digits. Add those up and I get 36. And I divide that by the last digit, which is 9, and I get 4.0. This is a valid Bennett social insurance number. They simplified Bennett social insurance numbers just for this purpose. Okay. If the last digit were, say, 8, then I would divide by 8. I would not get 4.0. I would get whatever 36 divided by 8 is. It's 4.5. And that would not be a valid social insurance, valid Bennett social insurance. Okay, so here's some notes that you might need for this little challenge. Use VAL to convert string characters to numeric versions. In other words, digit equals val digit string. We'll convert a character 8 to a value of 8. Use the int command to find the integer portion of a value. So for example, if number is 3.2 and number equals int of number would produce the 3. So int just takes gets rid of the decimal part. To check to see if it's a number, simply use this statement. If number is equal to the int of the number, then you know that the original number was an integer, and then in this case here, the SIN number would be valid. I can help you with that if that's not clear with you individually. I'd like you to make the program GUI by using Freeform, and I would highly recommend that you modify the password checker program that I provided for you. Use that as sort of a base template to create your social insurance number checker program. That is all for lesson 2.